Hi, this is Math 1650, and this video is over 4.3, which we're going to look at what's called the at least one rule, and then we'll look at what's called conditional probability. Both we have kind of seen already, but we're going to more define the process here for both of these. This is going to be a little bit of a quick video. So the at least one rule looks at the fact that the complement to at least one is the probability of none. So you either have none that happen or at least one trial event A happens, but there's no other in between there. And we did one that was similar. Let me go back to it. It's with the female babies. We were looking at 12 babies and looking at, in a sense, them being all girls. But we can look at it as at least one boy would be, one of these girls not being a girl and being a boy. And so it's set up the same way when you end up with having a exponent there for how many trials you have. So let's just do an example here. A couple having at least one girl and 3 boys. We're going to use event A to be at least one girl in 3 births. So, if 2 girls are born, that's fine, that's at least 1. If 3 girls are born, that's fine, that's at least 1. If 1 girl is born, that's fine, that's at least 1. If no girls are born, that's the opposite. So the complement to this is no girls are born. So what's the probability of not having a girl? Well, that's 1/2. What's the probability of not having a girl in 3 trials? That's 1/2 times 1/2 times 1/2, which is 1/2, which is 1/8. Right, so what's the probability of having at least one girl in 3 trials? It's going to be 1 minus the 1/8, which would be 7/8. Or we can write this as 0.875 or 87.5%. Alright, so the at least one in n trials is 1 minus the probability of none in n trials. And the probability of none in n trials determines that probability for one trial raised to n exponent. Alright, so in this example, we're looking at data DVDs in lots of 50. They have reported a defect of 0.5%. So the probability of a disc being defective is 0.005. And so it follows that the probability of a disc being good is 0.995. We want to know what is the probability of getting at least one defective disc in a lot of 50. So event A is at least one defective disc in 50 discs. Right. So not A would be no defective discs. In 50 trials or 50 discs. Right, so the probability of not having a defective disc is 0.995 based on what's the probability of disc being good. And then in That's in one trial. In n trials, this is going to be raised to the 50th power, since n is 50. Okay, and so the probability of A then is going to be 1 minus 0.995 raised to the 50th power. And that will come out to be 1 minus 0.778 or 0.222, 22.2%. Okay, so that's at least one rule. Conditional probability. This is the probability of an event after additional information is obtained that some other event has occurred. Okay. Now, we've seen this symbol before when we were talking about dependent events, where we have, drawing cards, maybe we draw an ace, and then we want to know the probability of drawing the second ace, and we didn't replace the first ace, so the probability has changed based on that. We assumed that the event A has happened. Okay. That's the only difference is, in this case, we know event A has happened. The math works out the same, so it's much like assuming, but this is more of a define of how we would find it, and so it's really just a little bit of a splitting hairs in a sense between this and what we did for the dependent events. But the math is mostly the same, and you can do a lot of this intuitively, but I'm also going to show how to do it following the equation. All right, so the probability of event B given event A has happened is equal to the probability of event A and B happening at the same time over the probability of A happening. Right, so let's just go through the examples. We'll start out with some of these are just going to show the difference between finding the probability of a regular event and finding it with given some more information. So if we want to randomly select one senator, what is the probability of getting a Republican based on the data we have there? So we see that we have 46 male Republicans and 5 female Republicans. So the probability is going to be 51. Let me wait for it to save. It's going to be 51 out of the total here is 100 senators. This is 0.51, 51%. Okay, now we'll do one that has some given information. Let me erase the little circles here. If we randomly select one senator, what is the probability of getting a Republican given that a male was selected? Right, so the male was selected, so we're only looking at that data. And we want to know the probability of getting a Republican there. Well, the probability there of a Republican given a male is going to be 46 over the 86 males. And this works out, let me put in the calculator. 0.535 or 53.5%. Now let's actually use the formula, because you notice I just did that intuitively by looking at how many Republican males out of how many males. If we use the formula, do it with a different color. Looking at the probability of a Republican and a male over the probability of just a male. So Republicans and a male, there's 46 male Republicans out of 100. And then the probability of just a male is 86 out of 100. So this works out to 46 out of 86. Since the hundreds cancel. Which is again 53.5%. Somehow it switched back to black. Anyways, let me just do a line in. So that's how you would follow the equation that we have for this. If we select one random senator, what is the probability of getting a female? Well, there's 14 females. Out of 100, that'll be 0.14 or 14%. If we randomly select one senator, what is the probability of getting a female given an independent was selected? So probability of a female given an independent. Well, we have independent, so we're just going to look at those values. That's the given, and there's 0 out of 1 independent, so it's 0%. Again, if we use the equation, probability of a female and an independent over the probability of a independent. We are looking at female and an independent, there was 0, and 0 out of 100 to be specific, and probability of independent is 1 out of 100. It still works out to 0 over 1. Or 0%. Alright, so that's how the condition property works. A lot of it can be looked at intuitively. It helps kind of narrow down the data instead. But this is the end of chapter 4. Next video will be starting chapter 5, which will start with what's called probability density and builds on the idea of probability. Alright, I will see you then. Bye.